So first quiz review thing, let's talk about graphing. So let's say we have y equals -2 times 1/2 to the x plus 1 minus 3. So if I want to make an xy table from this, how do I typically choose my x's here? H minus 2, H minus 1, H plus 1, H plus 2. So in our case, what is the value for H? H equals -1. So I have -3, -2, -1, 0, and 1. And then to find those y values, what's the best way to do that? Yeah, I'm going to use my graphing calculators because I can input this equation and have it output all the y values for me all at once. If you had trouble using your graphing calculator to do that all at once, what could you still do? Plug and chug them one at a time, right? But in the interest of getting this thing done, let's not do it that way. Sound good to you guys? So I'm going to clear out all the crapola kind of in my way. So I have -2 times. And now I'm going to try to be careful here because I have this fraction. I need to make sure I put the fraction in a parenthesis. If it was just like the number 5, you wouldn't need to make sure that was in the parentheses, but with the fraction there, we have to be a little bit more careful. And then, what was it, -3 at the end, I think? So there's that. So once I have that typed in, I'm going to go to my table set. So I'll press second in window. The value that my table needs to start with is -3. And my table is going up by 1s. So that's all set now. And then I press second in graph. And that's going to spit out my values. So -11, -7, -5, -4, and then -3.5. -11, -7, -5, -4, -3.5. Everybody happy with that? Go back and look and make sure you put the parenthesis around the 1/2, or you didn't put the -3 in the exponent or something silly like that. You have to press the right arrow after you have the +1, so the -3 is out of the exponent. So you have to put a parenthesis around the x plus 1 after the caret symbol. Everybody happy with that? There's one other piece that we need before we start drawing the graph of that. What's that one other piece? All exponential functions have a horizontal asymptote. How do we find the horizontal asymptote? Y equals k. So in this case, it's y equals -3. Everybody happy with that? Okay. So now I'm ready to kind of draw my graph. 1, 2, I don't want to count down to 11. 2, 4, 6, 8, 10, 12. 1, 2, 3, 1. So I'll start by drawing in my asymptote. Remember, I went down by 2s, so my horizontal asymptote's coming in here somewhere. And then I have -3, -11, -2, -7, -1, -5, 0, -4, 1, -3.5. My function is coming in like this. Everybody happy with that? Okay. So if I want to do the domain and range for this, there's two ways I could do this. One, I could look at the picture. And really, the domain, I don't even have to look at the picture. What's the domain for any exponential function? all real numbers. So no reason anybody should ever get an exponential function domain wrong. If I do this by looking at the picture, notice that my graph here, all of it is below what value? -3. So just y is less than -3. So if I have the picture, it's really easy to kind of tell it's either greater than the asymptote or less than the asymptote, just depending on which side of the asymptote your graph is on, right? Easy enough. If you wanted to go by the equation, you can say, like, if the a is less than 0, it'd be y less than k. If the a is greater than 0, it'd be y greater than k. If you prefer to kind of think about it as a rule, you can think about it that way, that the a value is going to tell you whether you're going above or below the asymptote. Is everybody happy with graphing one of these things? Should be relatively straightforward, right? These are honestly pretty easy things to graph because there's not a ton going on. Let's do a getting the equation from a graph problem. Sound good to you guys? Sure. Okay. So let's say that we have, we're given this graph. So the equation what we want is we want something of the form a times b to the x plus h minus k. So one of these, or to write this equation, then we need to determine the value for a, b, h, and k, right? One of these letters is easy to get. I can get it automatically just by looking at the graph. It is the k. What is the k? -1, because the asymptote is the k, right? Okay. The next thing we're going to do is we're going to find the h and the a. So I'm going to assume one of these points is the h point. Which one would I want to assume is the h point? Yeah, 2, -1/2, because it's on the curvier part of the graph. So that tells me h is 2, and then it tells me -1/2 is equal to a plus k. Well, we had already found k in the previous step, right? So when I solve for a, I get 1/2. Kevin? You may. Is everybody happy with that? Okay, the last thing I need to do is get my b value. To do that, I'm going to use the second point as an xy. So if I plug everything in, my y is 4, my a is +1/2, my b is what I'm solving for, my x is 1, my h is 2, and my k is -1. So now I'm just going to solve this equation for b. Everybody good with that? So I'm going to add 1 to both sides, and then 1 minus 2 is -1. Now to get the b by itself, I'm going to multiply both sides by 2 to cancel the 1/2. And I know b to the -1 is 1 over b. And then I will, to solve this, I'll just kind of cross multiply. So I get 10b equals 1, or b is equal to 1 over 10. So my final answer I would write then would be 1/2 times 1/10 to the x minus 2 minus 1. Brooke?
Why isn't it +1 instead of -1?
It's
Oh,
plus
sorry,
k.
sorry.
I might have said minus k on accident. I meant to say plus, though. Evan? Because 2 times a half is 1, right? So when I multiply it to both sides, it's just multiplication. I can multiply in any order I want, so I multiplied the 2 to the 1/2, and that just canceled the 1/2, right? Claudia? Because the formula is, oh, boy, that's a mistake, x minus h. Jeepers creepers. Thank you, Claudia. My apologize. Mm-hmm. So again, there's not a difficult problem to do, like steps-wise, like there's no complicated mathematics going on, but you do have to remember like how you get each of these little values. But none of the arithmetic is terribly difficult, and none of the steps are super difficult. You just have to remember that, like, okay, the k comes from the asymptote. I find the h point, that gives me the h, and then the y value is it's a plus k, that gives me the a, and then to find the b, I just plug in the other point and solve for b kind of thing. So it's the same kind of procedure over and over and over again. The only thing that could get difficult about this is the numbers might get a little gross, but it's not so bad. And then again, if I wanted the domain and range for this thing, I'm given a picture, right? I should be able to do the domain and range for this right away. What's the domain for this going to be? All real numbers, because it's exponential. And the range would be greater than -1, right? Because it's everything above the asymptote. Because the graph is all the way above is always above that asymptote. So again, like those should be easy, especially when you have the picture. It's just which side of the asymptote do I want? Or you could wait to the very end and use, the a and k from your answer down here, but then you run the risk of if you screw up the a and k in the problem, you'll get the domain and possibly get the range wrong if you wait to your answer rather than doing it from the picture. So I usually try to use whatever they're giving me in the beginning to figure out my domain and range so that if I make a mistake on the problem, I don't screw up the domain and range also, when I could have just gotten it from either the equation or the picture, whichever one they give me in the problem. Does that make sense? Okay. And then the last set of problems are these story problem style problems. So for this, you'd want to remember that we have these 3 models that we used. So we have the exponential growth model, the exponential decay model, the discrete compound interest model, and then the continuous compound interest model. And you'd probably need to remember what all these letters represent. So if I look at the growth model, V of t is the value at time t. A is the initial amount. R is the rate of change written as a decimal. Most oftentimes that rate's going to be given to you as a percentage. You need to make sure you change that percentage into a decimal. And then t is time. And typically for these growth and decay problems, the time would match whatever the rate is given in. So if it's changing like 7% per minute, the time would be then in minutes. If it's changing 7% per year, the time would be years, right? So just whatever the rate is will give you what quantity the t should be. Notice what's the only difference between the growth and decay function? Yeah, just that minus sign there. So it should be easy to tell them apart. And all the variables mean the same thing in the growth and decay. Yep. In the compound interest, or the discrete compound interest formula, V of t is, again, the value at time t. P is the initial amount. R is the interest rate as a decimal. Again, almost always that would be given to you as a percentage, so you got to make sure you convert it. N is the number of compounds per year. That's going to be given to you in words in the story problem. So if it says compounded annually, N is 1. If it's semi-annually, N is 2. If it's quarterly, 4. If it's monthly, 12. Weekly, 52. Bi-weekly, 26. Every other week is bi-weekly, so half of 52 is 26. I'm just going through possibilities. Bi-weekly is important, though, because how often are most people paid? Bi-weekly. Most people get a paycheck every other week. So it's not an uncommon, increment to have interest compounding. What do we do? Monthly. We did that already, didn't we? Daily. 365. Okay. So those are probably the most common values for N. And then T is time in years. Almost always in these compound interest, the time is in years, because that's usually how we value investments, is the yearly performance. Interest rate. Yep. And if we look at the continuous one, again, V of t is the value at time t. P is still the initial amount. E is a number. It is that irrational number, 2.71, yada, yada, yada. It is not a variable. It is on your calculator. It's a constant like pi is. So nothing goes in place of E. Again, that's a common mistake I see students make with this formula, is they're trying to plug something in for E. E isn't a variable. E is a number. R is the interest rate as a decimal, and T is time in years. And when I'm reading my story problem, how do I know whether it's a continuous situation? What phrase will you see in the story problem? Compounded continuously. It needs to say that in the problem for you to use the continuous compound interest formula. If it says compounded and then any increment other than continuously, it is the discrete one. So if it says annually or semi-annually or weekly or monthly or daily or hourly or secondly, all those are discrete. If it says compounded continuously, then it's continuous. I guess the other phrase you might say, like compounded every instant, would also classify as continuous. Right? Because how often is an instant? More than every second. It's all the time, right? Every instant. An instant is less than a second. It's less than a tenth of a second. It's less than a millionth of a second. It's less than a nanosecond, right? It's like every instant. Everybody okay with that idea? So these are the 4 formulas you'd want to make sure that you can use. I would probably say you should have them kind of memorized. It's not too much. We've used them quite a bit already, so you should hopefully remember most of them. But that's not so bad. Let's do an example. All right. Mr. K buys a comic book in 1980 for 25 cents. He sells that comic book in 2018 for $765. What was the growth rate for that comic? So, which model would I be using here? Growth, decay, compound interest, discrete, or continuous? Growth, right? Because clearly this comic book is increasing in value. Everybody agree with that? Okay. And which which quantity from this formula am I going to be solving for? R, right? Okay? So let's fill in everything else. What is my V of t? 765. My value for A? Yep, 25 cents or 0.025. And my value for T is 38, because there's been 38 years from 1980 to 2018. Everybody agree with that? Okay, to solve this, the first thing I'd want to do is divide by the 0.25. Okay, so that gives me this. Then what would I do? Can you distribute an exponent across an addition or subtraction symbol? No, you cannot. You could graph it, I suppose. Why don't we just take the 38th root of both sides, though? Everybody okay with that? When I do that, I get 1.2, let's call it 0.4. And then if I subtract 1 from both sides, I get 0.24 or 24% per year. Okay? So again, what's the only one that you really need to, what's the only quantity that you're really going to need to graph to solve? T, right? And really only for a couple more days will we have to do that. We've already been introduced to the tool that we need to be able to solve it algebraically, that being the logarithm. We haven't done a lot of example with that yet, but that's the only quantity that you would need to solve for by graphing. Everything else we have the tools to solve for algebraically, although as Brooke suggested, you could still solve this equation by graphing. You'd have to be a little bit careful about what your x min and x max would be for here. You'd want 0 and 1. Why 0 to 1? Because R is like a percentage, so typically your percentages are going to be between 0 and 1 when you convert them to a decimal. Because 0% is 0 and 100% is 1. So you have to be a little bit careful with your viewing window there, Brooke, but you absolutely could have still graphed that, and it wouldn't have been incorrect to do that. I just wanted to point out that this was one that we did have the algebraic tools to solve. Let's do one more example. I think we probably have about 5 minutes left, so... So here we'll ask which investment is better. $5,000 invested at 3.6% interest compounded weekly for 6 years, or $4,000 invested at 4.2% interest compounded continuously for 7 years. So to answer which one is better, I'll ask you to justify this mathematically. So if you just said option 1 with no work, I would mark it wrong, but I don't think anybody's kind of silly enough to think that all I really want you to do in this question is to say option 1 or option 2 and just guess at it. So for option 1, which formula should I be using? The discrete one. So I will calculate V of t. What is my value for n here? 52, right? Why 52? It's weekly. For option 2, what am I doing? I'm doing the continuous formula. So I'm doing the PERT one. And I'm just going to type these two into my calculator and see which one gives me the bigger value. Any guesses as to which one's going to be better? Yeah, I really have no idea. It's like totally unclear. So this one is 62.05 and 5 cents. I just made up some numbers. And I tried to pick something that there was enough differences between the two of them that it would be kind of ambiguous as to which one would be better. So if you were just guessing, you all would have guessed wrong. That it was too much to overcome that $1,000 head start investment one had. Even though if you look, the investment 2 made more money over that 7-year time span, but option 1 you net more at the. I don't know how you would answer this then. Maybe I should say which one is more valuable, right? And then clearly option 1 is the better value there. Okay. Did this